Welcome to Badger Talks Quick Picks, which brings exciting happenings, resources, and talent from your UW flagship campus to the people of Wisconsin and beyond, demonstrating the power of the Wisconsin idea, one connection at a time.
Hi, I'm Dave Lovelace. I'm a research scientist at the University of Wisconsin's Geology Museum. And today on Badger Talks, I'm going to be talking about some of the work that we have done over the last around 10 years, really, 10 to 12 years. And this started basically after I finished my dissertation as a PhD student in the geoscience department at UW-Madison. Soon after, I began to work at the museum as a scientist. And part of the job that we do is, we host undergraduates in the lab, they volunteer, we mentor them in both the research aspect, museum docentry, as well as field work. And so part of our program is bringing undergraduates out to the field, and the field area that I work is the red rocks, the Triassic aged rocks of Wyoming. And so what we're going to talk about and walk through is what we've basically done for the last decade to build up a pretty good story of what's going on out there. So this really is a story about the intersection between Madison and the Chugwater. And the Chugwater is the name of the big red rocks that we see in the Wyoming area and in northern Utah. So these red rocks are a fascinating area, and they have a history of being poorly studied. And as an undergraduate at the University of Wyoming, we were always told if you're really in trouble, the professors are going to send you out there. But I have to say, the reason they send you out is there's no fossils. So I wish this was all rainbows and sunshine for us to talk about. But the real story has been, Breithaupt summed it up well. Triassic research in Wyoming is generally ignored. These formations are perceived to be too difficult to work and generally unproductive, which is why this unit really wasn't worked from 1928 until 2012, whenever our field crews really started going strong out there. So we talk about the Triassic, but when exactly is it? Well, if we look at deep time, Earth's deep time here, the Triassic is part of the Mesozoic period, right in the middle, and this is the first part of the age of reptiles. And our unit, where it sits in the Triassic time frame, is right here, around 230. Now, we're going to talk about the details and how we got to that. But what I want to point out is the very first dinosaurs that are seen in the world are seen around 230 million years. In the northern hemisphere, though, the very first dinosaurs that show up are much younger. They're much closer to 222 or even younger. The first sauropod, the first ancestor of the long-necked, long-tailed dinosaurs, doesn't show up until about 215 million years ago. So there's like a 15 million year gap in the northern hemisphere. So it's a pretty big deal in vertebrate paleontology and our understanding of dinosaur origins. So this is the time period we are going to focus on, is the Carnian stage. And the Carnian runs from about 237 to 227 million years ago. And if we look at the distribution of where the first dinosaurs are found, the oldest dinosaurs in the world, they're all from the southern hemisphere. Most are from Argentina and Brazil, with a couple now showing up in Zimbabwe and India. So the story that we want to talk about is, our understanding of dinosaur origins and how the northern hemisphere really plays into this, how it fits in. So the very first dinosaurs that were found were really found in England, and then some of the earliest dinosaurs from the Triassic in North America were from the Western US in the Four Corners area. Now, if we look at these dates, the Southern Hemisphere, when the oldest dinosaurs started to being found, they were all from the Southern Hemisphere. And until 2007, really, we didn't have anything even close to the ancestors of dinosaurs in North America. So there's a big story about what's going on. And so the hypothesis was that dinosaurs originated in the Southern Hemisphere, and it wasn't until 10 million years later or so, due to climate changes within the Triassic system, the dinosaurs were able to effectively migrate northward, where they began to take over and started their global dominance. Well, in 2010, I was taking undergraduates out to the field as part of my dissertation research, and we were camping on a group of rocks at a campground that I used to play at when I was a kid in Wyoming, near Alcova Reservoir, and we found a couple chunks of bone that were fascinating, and we didn't know exactly what they were, but this was the first Triassic bone that had been really found or talked about for many, many decades. And so it was pretty exciting to us, especially growing up there where you don't go to the Triassic to look for fossils. So that was the first thing that really kind of set our program whenever I started at UW. It turns out that little jaw that we found is part of a rhynchosaur, little reptile, and that was part of its upper jawbone. And so if we look here, the cool thing is, well, the cool for us is that that group of animals goes extinct at 227 million years. That was our first clue that we had some pretty old rocks. Now, to give you somewhat of a sense of what we're really dealing with, trying to find and talk about the earliest dinosaurs, is if we were to go into the Cretaceous and look for dinosaurs, you are actually 20 times or more likely to find a dinosaur in the Cretaceous than you are in the early Triassic. So it is a rare and difficult phenomenon to try to find, as one would say, a needle in a haystack. And so we put together our undergraduate teams that are volunteers in the museum, students from across campus, go out to the field with us, and this became our Team UW. This was the folks that were going out to really try to answer this problem. And really, we ended up being CSI Triassic. So the idea that we are going out looking for different clues, we got super lucky. The very first year that we were out, 2013, we got these two bones. And I'll talk about them a little bit more in just a minute. But I want to say this was super exciting for us when we first saw them, because we're like, yeah, okay, they look kind of dinosaur-like, but there are no dinosaurs from the Triassic of Wyoming. So this is kind of a big deal. It might be the first Triassic dinosaur from the state. In 2013 as well, we went out and found a couple of sites that ultimately became very productive for other types of animals and giant amphibians that you can see in the lab and in the museum today. As well as in 2015, we found another site, and this was really our third clue of what's going on in the Triassic of Wyoming. See the little rib bones here. There are actually whole skeletons that are preserved in these burrows. So we continued to excavate the burrows. We looked for more of the dinosaur specimen, and we continued to excavate the giant amphibian quarries. And it was around the time of the pandemic. So we were digging in these quarries until really the pandemic hit and we couldn't go out to the field. During that time, we had all of these clues that I've talked about that we're trying to write up and actually present. So we reached out to the tribal community in Wyoming and worked with their students. And in 2022, we ended up going to the field. And we discussed the whole idea of how names are given to specimens, to scientific animals, both fossils and modern. And this was actually documented, this whole excursion and the concept behind it, in a documentary called What's in a Name? And that is going to be shown at the Wisconsin Film Festival, April 6th at 5:30, which is going to be super exciting. That's the world premiere. So this process was super fun, and it's ongoing. It's a partnership that's still going on. And students there helped collect samples of rock that then were analyzed. And we ended up getting our very final data that really cemented this thing. So clue one, we had a rhynchosaur, right? We know it went extinct about 227. That got the name Basiawa Ja'awusat. So that is an Arapaho name for this little reptile. Clue number three was these burrowing animals. And we scanned those things at the synchrotron in Australia and ended up getting some fantastic data, described this animal, and that is Nanimbihan Dukudaka. And that is an animal that is important to the Shoshone people. The last one is this little dinosaur bone. This is part of a dinosaur skeleton, and we have a few other elements, and it fits into the story of early dinosaur evolution, and this is Avetum bonduivici. And so the final clue was we got an age for this rock, and it is about 230 million years, which is the same age as the oldest dinosaurs in the world. So we're starting to fill in the story. We're understanding more of the dinosaur evolution. We know that Avetum is Northern Hemisphere's oldest dinosaur, filling almost a 10 million year gap. we've started to find a number of new specimens throughout the unit, and that has kind of led to the story of the dinosaur fauna of the Northern Hemisphere. Pretty exciting stuff. We're continuing to work both with the tribes and out in the field, and I want to say thank you so much for listening, and enjoy your day. This has been a fun research project, and anytime you want to see more, stop on in the museum.